Good morning, everybody. Today, let us start with our lecture number 4, that is potential energy. Let us start with it. What is potential energy? An object can store energy due to its position. When any kind of object it stores energy because of its position, the energy that it takes, that is the potential energy. In other words, energy stored in a body by the virtue of its position or configuration, that is potential energy. The energy that it stores because of its position, by the virtue of its position, that is potential energy. We will do some examples to learn it more. It is a scalar quantity. What is the scalar quantity? Scalar quantity means it is the that quantity that have only magnitude but not direction. Generally denoted by EP. Yes, it is denoted by EP. That's capital E, and in its foot that is a small p. EP. Therefore, EP is equivalent to mgh, where m is mass, g is acceleration due to gravity, and h is here h is height of the object. SI unit, that is standard international unit, is joule. It is denoted by capital J. And let us know about it more, to understand it more with some examples. So let us start. Hanji, examples based on potential energy. First of all, rubber band. A boy is that we are stretching a rubber band. Like, as we provide energy, external energy, as we are working on any kind of object, it gets stretches. Means we are providing some energy on the object. Means we are doing some work on the object. Then that object possesses some energy into it, and then it takes potential energy. It stores potential energy into it. Similarly, as we stretch the rubber band, we are doing some work over it. We are giving some energy to it so that it gets stretches. So that energy which it stores in the energy that we are providing from outside, that is what potential energy. Spring, similar is with the spring. As we are stretching the spring, we are stretching it more, and we are providing external energy to it, that it gets stretches in the virtue of its position, that is potential energy. Toy car, yes. What do we do with the toy car? This is a car, and we wind the key. There is a key by which a toy car, when we wind it, and then the toy car moves. So what we are doing here, that the toy car, when we are winding the key to the toy car, what it possesses, what we provide to it, we do some work to it, we give some energy to it. So the energy that the toy car possesses from us, that is the potential energy which will store in the car. And after that, after winding the key, it will start moving. Means it will come in motion, and obviously the energy that comes in the motion, that is the kinetic energy. So the energy that the object stores by the virtue of its position, here the toy car is storing the energy, that is the potential energy, and whenever it will be in motion, it will gain kinetic energy. Here also, by the virtue of its height, now it is at some height here. By the virtue of its height, the object will possess potential energy. And as soon as it will move from here, the object will come in the form of kinetic energy over here. Similarly, if a ball is thrown, whenever it is at some height, it is at some position, we are doing some work by bouncing the ball. So whenever it will reach its position, by the virtue of its height, the energy that the object will gain, that will be the potential energy. And when we will release down this ball, the energy the object will gain will be the kinetic energy. Yes. Now, what is gravitational potential energy? The object increases its energy when raised to an height. It always, whenever we are providing, object itself can't go by itself to any height. We have to provide some external source or external energy to take any object to the height. Obviously, it will, if we are doing any external source, we are putting any external effort from outside, we are doing some work over it, we are providing some energy from external side, obviously that object will gain some energy whenever it is taken to the height. Work done on it against the gravity while being raised. Whenever we are raising any kind of object, obviously the work is done against the gravity. Obviously gravity pulls us down, so the work is done against the gravity to take the object to any height. Energy present in such an object is gravitational potential energy. So yes, we are doing some work against the gravity. So what we say, that the energy that is present in such kind of object, that is gravitational potential energy. Gravitational potential energy of an object at a point above the ground is defined as work done in raising it from the ground to point against gravity. Obviously, gravitational potential energy of an object at a point above the ground, it is at some point above the ground, and it is defined as a work done. Obviously, we are doing some work to raise this object. We are doing some work to raise that object, and that work is done against what? That work is done against the gravity. Obviously, the work is done against the gravity. We are doing some work against the gravity. So that is why the gravitational potential energy of an object, it will gain some gravitational potential energy of an object at a point above the ground. Yes, it is defined as a work done. Obviously, we are raising the object to any height and from the ground to any point. So we are doing it against gravity. That is why the name is given gravitational potential energy. Let us proceed more. Now we will derive the potential energy now. We will do some derivation of potential energy now. Let us start with it. Now what is it? Let us consider an object of mass m. An object is there, it is having some mass m, and let the object be raised to the height h. The object is being raised to the height h from the ground. To raise object, force is required. We require some force, and obviously we will use some force, and let we take that force be as F. The minimum force required to raise the object should be equal to the weight of the object. Yes, obviously we can only raise that kind of object, any object. It should be at least the work which we will do, the force we will apply from outside, that should be equivalent to, at least should be equivalent to the weight of the object. Otherwise we can't raise that object. At least we should have that much, we should use that much force to raise the object as much that of the weight. So it is a minimum force required to raise the object, and that should be equivalent to the weight of the object. And obviously weight is also a kind of force. So weight of the object is what? M into G. What is M? That is mass of the object, and G is acceleration due to gravity. And obviously the formula of weight, as we know, that is mg. So let the work done to raise the object be W. So obviously we are doing some work, we are doing some external, we are putting some external energy over it. So the work is done against it. That is what? That is force into displacement. As we know the formula of the work, that is force into displacement. So what the force we are using? We are using the force, minimum force over here, that is equivalent to what? That is equivalent to weight. So obviously we will take that force here, that is mg, and the height already we know that as we are displacing this object towards some height h. So obviously that displacement is done to some height h, so we will take it as h. So what the formula we will get, that is potential energy, that will be equivalent to mgh. So now what is the potential energy for different paths? Work done by gravity depends on the difference in the vertical heights of the initial and the final position, but not on the path along which the object is moved. So what is there? What is the thing here? The potential energy is same for the different paths also, but the initial point and the final point should be same. Okay, so what they are saying, that work done by gravity depends on the difference in the vertical height of the initial and the final positions of the object, but doesn't matter what the path it can cover. We can go, if you want to go to the terrace, and we can use the stairs also, and we can go to the other home, then jump, and then we can also reach to the terrace also. So there are the different paths, okay. In our home also there are the different paths, so we can to move reach up to the terrace. So yes, the work done will be same over here. So what will be, we need to only know the initial position should be same and the final position should be same. So it is irrespective of the path. So it doesn't matter about which path it is covering. Here a block is raised from a position A to B. A block is raised from position A, let this position be A and this position be B. Here a block is raised from position A to B by taking the two different paths, which is, one is this path, that is the straight path, and one is this path, that is taken with the two different paths, right? So let the height AB की height क्या है, that is, let it be h, let this height be h, as it is also given in the picture. In both the situation, work done on the object, irrespective of their path, the work done that is done on the object, that will be always equivalent to the potential energy, and that is mg.